Okay, so let's look at some more intermolecular forces and some more examples. So in these examples, we're again asked to determine what intermolecular force exists in this liquid phase. So we start with our questions, whether or not the thing is polar or non-polar. Then is there the possibility of hydrogen bonding? So meaning is there N, an O, or an F with hydrogen present? Is there an ion dipole possibility in, and is there a mixture? So meaning is there a non-polar plus a polar possibility? Right, so our first question is H2O2 polar or non-polar? And the answer lies in how you draw it. So it technically has a bent geometry, and then it will be polar. So it means in A, it is polar. So that means we have dipole-dipole forces, not forces, forces. Okay. It also can have hydrogen bonding forces. And of course, all molecules have London dispersion forces. Okay. All right. Then chloroform, no, that's not chloroform, but anyway, CH2Cl2 is a tetrahedral structure. So basically you have a C and you have a Cl there. Into the back of the page, you'll have a Cl maybe. To the front of the page, you'll have an H. And then in the page, you'll have an H. And you'll see definitely there is a dipole. So in other words, meaning it is polar. So we'll have dipole-dipole forces. We always have London dispersion forces, but there's no hydrogen bonding forces. Okay, C is H2CO, also known as formaldehyde. Right. Polarity, yes, it means it's polar. If it's polar, it means we have dipole forces. There's always London dispersion forces present in something. There is H and O's present here, but it's not an OH bond that can be polarized. It's a CH and there's an O. So there's no hydrogen bonding, there's no ions, and there's no mixture. So those are the only thing that are present. D, we have ethane, so it's CH3, bond with CH3. It's non-polar. If something is non-polar, it basically just means it only can have London dispersion forces or induced dipole forces. Remember, all London dispersion forces are present in all molecules, and they're known as induced dipole forces, or London dispersion forces. And the last one, E, is a bit of a difficult one to think of, but you have a CH3. Well, if you haven't had an organic course yet, C, you have a CH3, you have an O, you have an H, there's an H here. And now we ask ourselves, is it polar? Yes, this thing is polar. There's a polarity towards that side. So it means we will have dipole forces. Can we have hydrogen bonding? Yes, there is an OH bond. So it means there is hydrogen bonding present. And all molecules have London dispersion forces present in it. Okay, so that's your tick list. So polar means dipole-dipole, non-polar means London dispersion forces, or non-polar means London dispersion forces only. Polar means dipole-dipole and London dispersion forces, technically. Hydrogen bonding is kind of like a special kind of dipole-dipole force added on the dipole-dipole force and the London dispersion force. And then iron dipole is, of course, mixtures, and nonpolar and polar mixtures also have a special dipole-induced dipole force that comes in. But we didn't look at mixtures here, so those two are kind of separate. But yeah, that is how we identify it. Of course, your knowledge of Lewis structures and structures in general play a huge role in this. I mean, if you drew peroxide linearly, for example, you would have said that it's non-polar. So then you would have said it only has London dispersion forces and maybe hydrogen bonding. Um, so that causes some issues. But anyway, we move on. Right, I'll see you in the next video. Thank you for watching.